What if I told you that long before humans ever launched our very first satellite, something else was already orbiting Earth, watching us from the dark? Forget modern UFO sightings. The proof has been hiding in our oldest star maps for decades. And science is finally catching up. For millennia, humanity has gazed into the night sky, assuming we are the sole curators of intellect in this immense cosmos. Across an observable universe spanning 93 billion light years, containing trillions of galaxies, the mathematical probability of our solitude seems infinitesimally small. Most of us can reconcile with the idea of microscopic life on distant exoplanets, or even intelligent civilizations thriving thousands of light years away. Yet, we struggle to accept a far more unsettling proposition: that they might already be here, watching from the quiet dark of our own cosmic backyard. The thought of technologically advanced craft, operating with unknown intent just beyond our atmosphere, challenges our sense of security. But what if evidence of their presence has been silently resting in our historical astronomical records, captured long before we ever launched our very first satellite into orbit? Unidentified aerial phenomena are not merely a modern fixation. Throughout history, humanity has witnessed anomalous events in the heavens, often attributing them to the supernatural. A sudden flash of lightning was the wrath of a deity, a passing comet, an omen of impending doom. As science matured, these mysteries dissolved into physics, transforming gods into electrostatic discharges and celestial portents into dirty snowballs orbiting the sun. Yet, some historical accounts resist easy scientific dismissal. On April 14, 1561, the citizens of Nuremberg, Germany, witnessed a baffling spectacle. According to local records, the sky filled with spheres, disks, and elongated rods engage in apparent battle, eventually falling to the earth in plumes of smoke, followed by the appearance of a colossal black spear-like object. While medieval witnesses viewed this as a divine warning, modern eyes see something different.
To a modern analyst, the descriptions of spheres, cylindrical shapes, and dark triangular forms match modern reports of unidentified anomalous phenomena, or UAPs. Recently, declassified military footage has renewed scientific interest in these encounters. However, historic testimonies like the Nuremberg event lack scientific rigor. We cannot extract physical data from a centuries-old newspaper report. We cannot analyze the composition of the fallen spheres, nor can we cross-examine witnesses who have long since returned to dust. Skeptics point to atmospheric anomalies, like complex sundogs or early fireworks. Without empirical, measurable data, we are left with nothing but speculation. To truly investigate the possibility of an anomalous presence near Earth, science requires thousands of objective data points, gathered by precise instruments. Remarkably, a team of modern astronomers may have found exactly that, hidden within 20th century star maps. Enter Beatriz Villarroel, a Swedish astrophysicist leading the VASCO Project, short for Vanishing and Appearing Sources, during a century of observations. The team's original mission was to hunt for vanishing stars, massive celestial bodies that were documented in historical sky surveys but have mysteriously vanished from modern view. To search for these disappearing giants, the team digitized photographic plates from the Palomar Observatory in California, captured during the mid-20th century. These glass plates represent a pristine record of the night sky from a bygone era, long before the sky became cluttered with human-made space debris. By comparing these historic records with modern digital surveys like Pan-STARRS, the researchers identified around 100 vanishing star candidates. But as they examined the plates from the early 1950s, they stumbled upon an anomaly that shifted their entire focus.
On a single photographic plate, captured in 1950, the team discovered a cluster of 9 distinct light sources. These transients appeared suddenly within a 30-minute exposure window, yet they were completely absent on plates taken just half an hour earlier. 6 days later, they had vanished without a trace. In a 2021 study, Villarroel systematically analyzed and ruled out standard explanations. They were not fast-moving asteroids, distant flare stars, or gamma-ray bursts. High-energy radiation from Nevada nuclear tests, which could contaminate plates, was ruled out as no tests occurred between 1949 and 1951. Most importantly, the light profiles closely resembled sunlight glinting off reflective metal surfaces. However, the world's first artificial satellite, Sputnik 1, did not launch until 1957. These objects were orbiting our planet 7 years before humanity ever reached space. Driven by these findings, the VASCO team expanded their investigation. In late 2025, they published findings analyzing over 100,000 transients recorded between 1949 and 1957. The sheer volume of these fleeting light points suggested they were not random plate defects. Instead, the researchers proposed a bold hypothesis. A significant portion of these transients were metallic, reflective objects orbiting within Earth's gravity well, likely in geosynchronous orbits. To reside in geosynchronous orbit, an object must sit approximately 35,786 kilometers above the equator, moving at a speed that matches Earth's rotation. If these historical glints were indeed physical objects reflecting sunlight from this orbit, it would imply that someone or something had placed artificial hardware around our planet long before the dawn of the human space age.
To test this hypothesis, the VASCO team devised an elegant scientific test utilizing the Earth's shadow. If these transients were merely plate defects, film, chemistry errors, or distant background stars, they would appear uniformly across the night sky, unaffected by our planet's position. However, if they were real, reflective objects orbiting Earth, they would rely on sunlight to be visible. Upon entering the dark cone of Earth's shadow, they would immediately go dark. Using statistical modeling, the team analyzed the spatial distribution of the transients. Their analysis revealed a significant, measurable drop in the density of transients within the Earth's shadow zone. Out of the vast data set, 349 specific transients fit this exact orbital profile, suggesting they were physical, reflective structures interacting with the sun's illumination within our planet's immediate orbital environment. Beyond their physical orbits, the behavior of these transients revealed even more perplexing correlations. When the researchers cross-referenced their historical database with public UFO reports from the 1950s, they discovered a statistical connection. On days when the public reported anomalous aerial sightings, the number of space-based transients captured on the Palomar plates increased by an average of 8.5%. This correlation is difficult to explain, as the public could not have known when a telescope was capturing fleeting glints in orbit. Even more startling was the link to nuclear activity. The data showed a 45% surge in orbital transients on the days immediately following terrestrial nuclear test detonations. Why would artificial objects operating high above our atmosphere exhibit such a sharp behavioral spike in response to the split-second flashes of our early atomic weapons?
This apparent connection to atomic energy aligns with long-standing accounts from military personnel regarding UAP interest in nuclear infrastructure. In October 2010 at F.E. Warren Air Force Base in Wyoming, multiple servicemen reported a silent, cigar-shaped craft hovering near missile silos. Simultaneously, 50 Minuteman, 3 nuclear missiles went completely offline, an unprecedented security failure that puzzled engineers. Decades earlier, in 1982, Soviet records described a similar event where a hovering UAP temporarily activated the launch sequence of several intercontinental ballistic missiles, which only aborted after the object departed. While these military accounts remain largely anecdotal, the VASCO Project analysis of historical photographic plates represents some of the first hard, statistical data correlating high-altitude transients with our nuclear activities, suggesting persistent, watchful presence monitoring our transition into the atomic age. As with any paradigm-shifting hypothesis, the scientific community responded with rigorous skepticism. The VASCO papers face hurdles, including rejection from popular preprint server AR-14, whose moderators felt the work lacked sufficient scholarly depth. Sean Kirkpatrick, former director of the Pentagon's All-Domain Anomaly Resolution Office, proposed that high-altitude research balloons or solar flares were more plausible explanations. A formal counter-study, led by astronomer Wesley Andre Waters, presented a detailed critique of the VASCO findings. Waters argued that to confirm these transients as real physical objects rather than plate flaws, researchers must examine the physical, non-digitized glass plates under a microscope. Plate degradation, chemical dust, or microscopic scratches on emulsion can easily mimic stellar objects in digital scans. When Waters' team applied a more stringent filtering process to the raw data, the statistical patterns began to shift.
Waters and his team asserted that after removing the background noise and potential plate defects, the statistical drop of transients within the Earth's shadow disappeared entirely. Furthermore, they noted that the Palomar Observatory was historically 35% more likely to conduct exposures during active nuclear test windows. Failing to account for this bias, they argued, created a false correlation between nuclear tests and transients. Villarroel quickly responded, arguing that Waters' team overfiltered the data, reducing the sample size from 100,000 down to just 5,000, thereby erasing genuine signals. Re-evaluating the telescope's scheduling bias, she maintained that an 11% surge in transients after nuclear tests still persisted. This academic debate highlights the complex nature of astronomical archaeology, where the line between a groundbreaking cosmic discovery and a microscopic speck of dust remains incredibly fine.
The scientific debate surrounding these pre-satellite transients remains unresolved, yet the methodology itself marks a creative leap forward. Searching historical sky surveys from the pre-satellite era provides a clean window into our past, free from the thousands of human satellites that now crowd our skies. If future peer-reviewed studies can verify even a handful of these transients as authentic, metallic, reflective objects, the implications will be profound. It would mean that we are not the first advanced technology to occupy this corner of the cosmos. We often view ourselves as the dominant intelligence on our fragile, pale blue dot. Discovering that a silent, patient observer has been tracking our progress from orbit since before we ever left the ground would fundamentally reshape our understanding of our place in this vast, quiet universe.